Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. We are still developing unassemblize tool, and we need to think about our ASM comparison commands. Okay. Good, so we currently use only these 4. We don't use these. Okay, let's think about this. Async process, ASM comparison command. Yeah, so right now in the runner, ASM comparison, it does a lot of things, right? It builds function matches. It builds function bundles, disassemble function matches. It does a whole lot of stuff. And then it builds a comparison results. Okay, we need to break this up, I think. Okay. Okay. So result bundles. Result bundles. Yeah. Process ASM comparison. ASM comparison. We need to say function bundle, function matches. Okay. So certainly we don't want the output comparison results, right? This definitely needs to be a separate step. Okay. The question is, should some of these things also be separate steps? Bundled. Comparison options. Bundle type. The method to group symbols with. So right now the matches are being so the matches are built for all. It doesn't filter anything. It's a whole thing. So if we ever run build function matches, it does a whole thing. But I think it's not expensive. It's probably somewhat cheap. Okay. Build function bundles. This one build function bundles. Matches. The UI will have different requirements than what the command line output does. Okay, but we can probably agree that the function matches need to be built once and be complete. Yeah, the function bundles. Match bundles, bundled. Disassemble function matches is only really necessary to do if we actually want to show it, if we want to compare it, right? Otherwise, it's not necessary. function matches. Okay. Build function bundles. Bundle type. Function bundles. Compiled. Build bundles. Build bundle. Build bundle. Function match bundle. We need to have a good plan for organizing the data. bundles. Yeah. Match bundles. Okay. Okay, so let's take some notes. So build function matches. This is always needed, right? Then let's make our window smaller. Move it here to the side. Good. So build function matches always needed. Build function bundles is strictly speaking optional. It's optional. Disassemble function matches should only be needed when actually when viewing the match. Or when requesting before, should only be needed maybe when before requesting compare. Same with this. Build comparison results. So this currently creates a huge big bundle. I think this needs to be broken up. Matches. Matches. Functions. I'm not sure about this one. Match bundle. Comparison. So the problem with this is it does a whole lot of work, which we maybe not want all at once, right? We only maybe want to look at one comparison. Matches. We probably want to have full control over our bundles and data. So the problem I'm seeing here is that the comparison result is part of the bundle. Yeah, I think this is a problem. This data layout is a problem. Essentially, we want our ASM comparison results to be flat data, have a vector of just comparison results, right? And then you can have different bundles pointing to the same results, right? Because right now what would happen here is if you wanted to have two bundles, like let's say you wanted to have a bundle for compilant and source file, then you would have to create two separate of these vectors. And both of them would contain an individual comparison results. Even though they could both, these bundles could both link to the same comparison result. So basically, just one comparison result would have to be established for a function pair. And then the result bundle could both refer to it. So I think this one needs to be in flat vector. It is here. We have a flat vector here, but it is part of the bundle. Matches. Okay, good. So okay, but when we have this, let's say we split this now, then what? Yeah. So let's say we have here a new vector. Comparison results. Matches. This is a hard challenge. Yeah, results. Oof. Build comparison results. So build comparison. So okay, how about we try to draft the kind of data we want. Sorry. So we probably want bundles, function match bundles. Okay, let's go to IMGUI app. Good. So we probably want matches. We want bundles. Let me see, bundles, function match, bundles, matches. Yeah. So here we can say compilant bundles and source file bundles. Compilant bundles, source file bundles. And here we put this function name to match index map. And then we probably want comparison results. comparisons. Comparisons. The comparisons linked to this function match. This one so right now, this construct here gives us no stable references. So this here, this one only remains intact if this one doesn't change. So if we ever reload one of the executables, then this whole thing and everything downstream would have to be rebuilt. Comparisons. Comparison. Got a spam here. So I think what we also need is string to index map for function name to comparison index, function name to comparison index map. Yeah. So essentially we have our matches, function name to index to match index, and we have the comparisons that refer to the matches, which currently don't have stable references. But okay, for now we can just say we always build this once to begin with, and this always built. This one is built on demand. Like let's say, okay, we want to compare this and this function, and then it will build these things. It will push this in here. This way we have full control. Like we can have a list of just functions, or we can have lists of compilants or list of source files. And then we can click on these things, and then it will show us all the matches for these things. So if we click on a compilant, it will show us everything that is in this compilant, and it will load all the matches. We'll make all the comparisons for these. Same for the source files. If we click on a single function, then it will just show us a comparison for this and just execute this. So this means we need command to build one comparison. We need a command to build these bundles. So this is one command, this is another command. Every time we append a comparison to this, it is a command. What is in here? Okay, and here we need a different structure. So we need something like struct asm comparison result bundle b. Let's call it like that for now. Change. So to do name. Function match bundle. Name match. So to me it looks like that this one and this one should be merged. Right? So that the match bundle contains links to the matches, but it also contains links to the results. Function. Well, what we can do is we compose. What is this? How is this used right now? Yeah, so the question is, should this be merged with the other or not? I mean, they will share the same name. Maybe they should be in one. It just pipes through the name here. It resizes to the match card, so it's all things the same, but it's a similar, it's a different vector. Well, comparison. Whoa. Yeah, the question is, do we want to keep these things separate, the bundles, or merge them into one? I don't know. Probably should be one because it belongs together in a way. Yeah, but how do we name it then? Function match bundles. Group. So picture, we make function groups function matches and comparisons of the same component or source file together. So we call it function match and comparison function match I don't know, ASM match comparison bundle. Matches comparisons. This will be comparison bundles bundle. Okay, and then we'll have this here bundle bundles. So function matches, it's just the matches where we disassemble, and then we have a string to index on this. We have ASM comparison results, flat vector, and we can also have a string to index map onto this one. And then we have the bundles, one for compilant and one for source file. And we build them separately when needed, when the user wants it. Yeah. Are we missing anything? Let's see. Runner. I don't think so. I think from a data perspective, this is all we need. We have the matches, which contain the functions. We have the comparisons, which link to the functions and contain the comparison records. Right, yeah. And it has the information about similarity and so on, yeah. Then we have a map. I wonder. Yeah, we need this lookup because What we could do is that the comparisons share the exact same indices as the matches do. We'll be right back. Okay. So, how about function match comparison? So I'm wondering, does the ASM comparison result also really have to be separate from this one? I mean, it could also be in the same. right? Because essentially it is treated that way. So if you look at runner, we have function, build function matches. Comparison results. So, right, that's about the bundles. Matches. Yeah, okay. So it was separate here. Yeah, I see. So the reason why this here is separate from this is because we had the data not like this is in one array here, but this we had organized in a way where each compilant or each source file would own this. And there could be only one. There could be only source file or compilant. Just one of these could own this. But it makes it inflexible because, yeah, then we can just have this one filter, right? So I say we take this stuff and we merge it together with function match, because essentially we want to have the function match. It has a name, it has the functions, and this thing, it does nothing else than linking here on this function pair, right? And it will always link to this. It won't link to two separate ones. It links to this function match. And so these things, these 5 things here, could be part of this. So then it's one unit. I think that makes it much easier to manage the data. You know, also much more straightforward to have this link, yeah. And then what it also means is that here it's implicit. So here then we would only need this. So basically, hold on, which you already have here, this match bundle. So we just need a function match and a match bundle, and we are done. We don't need the ASM bundle, blah. We don't need all this. All this can go away then. All this can go. Okay, that will be, yeah. And this, I think, will make the whole thing much more flexible. Yeah. There was a mistake on my part, the way I originally set up the data. Okay, but that's good that we have clarity. I think that is the right course of action. Get rid of these duplicated sets of data. Get it all into one piece. Have the function match and the comparison result in there as well. Okay, that's quite a bit of refactoring. Oof. Okay, that will be some work. Okay. then yeah, let's try to get this rolling. So we remove this here again. Then we take all these guys here. So I think we need to match bundle. Okay, I think we need to move all these things to the tippy top for starters. Yeah. Then we move this also to the bottom here. Okay, and then, okay, so this will be brutal, but we will let's take this, what we have commented out, and put it here. So we will take this stuff here and we put it here in the function match bundle, and we move this down here. No, hold on. This is wrong. What am I doing here? It has to go in here, function match. There we go. And then this is here, functions records. Then we remove this. Function matches. Okay, and then matches. Yeah, and then here we remove this. And then we fix here the functions. Yeah. Okay, this would be our new data layout, and I think this will give us all the flexibility we need. So basically, the function match points to the functions and also has the comparison records in there. It's all in one place. And then our bundles, our function match bundle, points to these things combined. Yeah, I think that's a good simplification. So that means this data is flat and different things can point to it. One map to have function to index, and then these bundles for compilant and source file. Right? So we have different ways to refer to this thing. Okay, there will be quite a bit of work then to adjust everything. So let's go to our GUI app. So here we would have the matches, then function name to match index map, yeah. And we no longer need this. And then we have function match bundles. And this one is a bundle with matches. Yeah. Yeah, this is a great simplification. Function matches. Yeah, this is all the data we need, I think. Yeah, and then we just have a whole bunch of commands to operate on this data. Or am I missing something? Function matches. String to index map, function match bundles, compilant bundles, source file bundles. Yeah, okay. Well, we now need to adjust all functions for the command line to work with this kind of data set. Yeah. Oof, this will be a little bit of a task. What's the time? 1 hour 30 already. Oof. Maybe we can take another break now. Yeah. Yeah, let's take a break and try to go in with full motivation in the next video. I have to say, this is a bit of annoying work. This refactor is not the most pleasant, but it is necessary. We need to get a grip on a good data layout. It's the most important, right? Because the way the data is laid out dictates how it's handled and how the logic works. So the fundamental design of how we lay out our data is always the most important. If we do a good job with the data layout, then everything else will be easy peasy down the line, because then handling the data will be straightforward and easy to do. But if the data is all over the place, then it's really hard to manage it, and you need all sorts of logic to accommodate and pulling data here and there and this and there. So laying out the data is really crucial, always. Yeah. And I think this way is good. We have a absolutely flat vector for all the function matches, and then we can link to it in any ways we want. Yeah. Yeah, I think that will work. And since now we also have these comparisons in the same object, that means there won't ever be a disconnect between the functions and the comparison records. They are always in the same thing. Yeah, they're always in the same. Yeah, that makes data more resilient to potential errors. Yeah. Good. The only downside is that you could say, okay, now we always carry this data, even though maybe we don't need to have a comparison, right? But I mean, you could make the same argument for this. Maybe, yeah, maybe one could say that. So currently we don't have any information on functions that exist on either side that don't have a match. Function matches. I think it will be valuable to also know which function exists on the left side and which on the right side, and they don't have a match. But how would we show this? Well, for this, function matches. Well, when you have a list of functions on either side, and you have the function name, right? So you have this map here, and you have function names on either side, and you want to know if it exists on the other side, then you simply we simply look into this map and see if there is a hit. And if not, then we know it doesn't exist on the other side. But we probably also want this to be stored in a separate container. Maybe. Matches. Function match. Function match. What does this contain here? Okay. Function match. Function match. Okay, how about we create a struct function single function match function function single. That's a weird name. Function function match. What's the opposite of match? Mismatch. Another word for mismatch. Another word for unique. Exclusive. Maybe call it exclusive function. Exclusive function. Then we just put the name and function. Then in the bundle we put std, put function matches, then we do function matches, unmatches. Maybe call it function unmatch. Function unmatch. Function unique, exclusive. Function no match. Well, function no matches. Well, it's a bit bad wording, isn't it? Function match, function match, function unmatch, mismatch, no mismatch, not function exclusive function, single function, missing function, unmatched function, matched function, unmatched function. Unmatched. Unmatched function. Yeah, maybe rename it to matched function. Matched function. Matched functions. And then this will be unmatched function. And unmatched functions. Matched functions, unmatched functions. And then this contains matches. std vector index t unmatches. Is that an invalid word? Unmatched functions. Pass a function from two executables that can be matched. A single function that cannot be matched. A single function in an executable that cannot be matched with a function. A single function in an experiment that cannot be matched with a function of another executable. Okay, matches. Maybe we rename it to matched. Matched functions and unmatched functions. It's a bit long, but that's okay. Okay, we will have a lot of compile errors now, but that's okay. So we have matched functions. Then we will have unmatched functions, and this will be a vector array, std array unmatched functions 2. unmatched functions. No, it can't be like this. That makes no sense. Actually, it does. Yeah, for both sides, one have a vector. Yeah, unmatched functions. Yeah. Then here we have functions name, and then we need another std array string to index map. Function match bundles. Function name well, it's questionable if that's really needed. Okay, but we probably in our bundles I think this also needs to be std array 2. What? Too few arguments? Why? Oh, okay. Okay. Unmatched functions. Function match bundle. I think this makes sense. Okay, but I think we do need lookup for this. Match functions. It's the array. Function name to unmatched index map. And here's matched index map. Maps. Function name to unmatched index maps. Yeah. So we have matched functions, index map to that, unmatched functions for both sides, left and right. Function name to unmatched, compilant bundles, which refer with indices to this and this. Yeah. 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 Yeah, I think this works. Probably. Maybe. Yeah, okay. Good. Let's see how much stuff is broken now. Yeah, a little bit. Asm Matcher. I think runner will be broken the most. Not too much. It's probably manageable. Okay, yeah. Then next video we will tackle this adjusting all code to accommodate the new data layout. But I think even after this is done, there still is a lot of work on the code to like separate steps things. So this is just step one, really. Yeah. I think this will be quite a bit undertaking to get this all broken down into nice steps. Yeah. This is a hard part, I would say. But once this is all laid out and the data is beautiful, I expect that building the UI for it will be good. Yeah. It's just we need to get the data in a good format. Good. Then yeah, I will take a break here. I wish you a great day or night. Until next time. Goodbye.